Hello everyone, this is our science teacher Tim Martin, and in this video I want to discuss solar eclipses. Solar eclipses are often known as one of the most beautiful events in all of nature. Let's take a look at how they occur. In this animation, we can see the moon orbiting the Earth. This diagram is to scale, showing the moon orbiting the Earth at 30 Earth diameters away. In this similar animation, I've highlighted the plane of the moon's orbit around the Earth. You may notice that it's tilted a little bit. The tilt of the plane of the moon's orbit helps explain why there's not an eclipse every time there's a new moon. When the moon is between the Earth and the Sun, the shadow of the moon is a little above or a little below due to the 5-degree tilt of the plane. There are two spots in the Earth's orbit around the Sun, however, where the planes do align. In this case, when the moon passes between the Earth and the Sun, it's possible for the moon's shadow to land on the Earth. Let's take a look at this with a little more detail. We'll leave the scale diagram. Please note this diagram is not to scale, with the Sun depicted on the left and the Earth and Moon on the right, and the moon's shadow falling on the Earth. You'll note right away that the shadow is complex. There is the penumbra, or partial shadow, and the umbra, or the complete shadow of the moon. In the umbra, none of the light source would be visible. In the penumbra, part of the sun would be visible. I'll never forget a particularly memorable penumbral or partial solar eclipse. The eclipse was due to happen on Christmas Day in the year 2000. I was with extended family, looking forward to getting out of the house for a while to view the eclipse. Unfortunately, the day was quite cloudy. I did get this picture of the eclipsed sun through some rather thick clouds. As I looked to the horizon, though, I could see blue sky, so I decided to get in the car with the telescope and drive south to see if I could position myself under the blue sky. None of the rest of the family decided to come along on this snowy Christmas day. I found myself in a parking lot of a grocery store. When a local highway patrol officer stopped to ask what I was doing, I had the good fortune of getting the telescope out. The highway patrolman and I had the opportunity to witness a spectacular event as the moon passed partially in front of the sun. There's another detail about solar eclipses that's really quite important. In general, the moon is 400 times smaller than the sun, but since the sun is 400 times further away, they usually appear the same size in the sky. Sometimes the moon is a bit closer. We say this is perigee. Other times it's further away at apogee. When the moon is further away, it won't quite cover up the entire disk of the sun. On the other hand, if the moon is closer, it will fully cover the sun. Let's take a look at the difference. Here's an eclipse that happened at apogee. Notice that the moon's umbra shadow missed the Earth. If you were standing on Earth when this happens, you would notice the moon gradually blocking out the sun over the course of about an hour. When fully lined, a ring of sun was visible. So an apogee eclipse is known as an annular eclipse. The moon's umbra shadow does not fully reach the Earth, and so it's possible to view a ring of sunlight. I had the opportunity to witness an annular solar eclipse back in 1994 in northern Indiana. Gradually, the moon took a larger and larger bite out of the sun until all that remained was a ring of sunlight. When I took this image, the moon was perfectly aligned between me and the sun. On the other hand, a total eclipse happens when the Earth's umbra shadow does touch the Earth. This animation shows the view from Earth. As the moon gradually slides closer and closer to the sun, it will again seem to go through all the partial phases. As the sun dims, whoa! An absolutely spectacular event. Let's take a look at that with a little more detail. When the moon is at perigee, or at a closer point in the orbit, it fully blocks the sun. When the photosphere, or visible surface of the sun is blocked, Then we can see the sun's atmosphere, or its corona. Keep in mind, the photosphere is 1,000,000 times brighter than the corona, so the only time it's possible to see the corona is during a total solar eclipse. Notice again on the diagram that the moon's umbra is touching the surface of the Earth. For over 40 years, I waited with anticipation for August 21st, 2017, the Great American Solar Eclipse. In this sequence of satellite images taken by the NOAA GOES satellite, we can see the shadow of the moon racing across North America. With plenty of time to plan for this eclipse, my family decided to rendezvous with the moon's shadow in central Nebraska. Initially, the campground where we were staying seemed to have some clouds, so we drove west. By the time we got to blue sky, the moon was already partially eclipsing the sun. The images below were taken with my cell phone using the small telescope to project the eclipsing sun. As the moon gradually slid in front of the sun, the light dimmed, birds began performing nocturnal behavior. On this hot summer day, the temperatures gradually cooled, the wind calmed, and the insects became quiet. And then we were treated to one of the most spectacular sights in nature, the diamond ring. When the last bit of the photosphere of the sun is visible, the corona starts to emerge around the perimeter of the sun, shining like the most beautiful diamond ring. Then the moon totally covered the sun. As we looked around the sky, we could see sunset colors 360 degrees around the sky while we were in the shadow of the moon. The word corona means crown. Here we can see the sun's atmosphere, or corona, shining in all of its glory. Then, 2 minutes and 35 seconds after the moon eclipsed the sun, the surface of the sun emerged on the other side, creating another spectacular diamond ring. You'll notice also, on the right-hand side of the sun, a little bit of pink. These are prominences, or glowing clouds of hydrogen gas above the sun's surface. The eclipse of 2017 was over. If you too would like to see a solar eclipse, mark your calendar for April 8, 2024 for the next North American solar eclipse. For a little closer detail, we can see the path going across Mexico, Texas, Oklahoma, Arkansas, a little bit of Missouri, Illinois, Indiana, Ohio, much of New York, and then leaving the United States in northern Maine. Closer to the time, I will be watching the weather very carefully because I intend to be close to that red line so I can once again stand in the shadow of the moon. This is Greensboro Day School's Earth Science teacher hoping to see you in the shadow of the moon in 2024.